Hey everybody, welcome to a video of Aaaand. First, as a quick note, I'm so sorry guys, but my video is not working. However, I try to fix it. And so in this video, I'm not going to be sharing video. Again, I'll be using a simulation. I'll put the link to this simulation in the comments below. So, in this video, we'll be talking about these. These are inductors. Inductors are basically like this. It's a wire wrapped around something like a tube. So, if we connect a battery here, and then have a light bulb, and then wires, we can make a basic conductor circuit. We're not going to connect this wire yet because it'll turn the light on immediately. So we're going to get a switch so that we can control the flow of energy. Now, we flip the switch and notice what happens to the light bulb. As you can see, the light bulb is getting brighter, but it gets brighter very slowly. For example, if we turn the voltage up in this battery and then disconnect the switch and reconnect it again, you can see that the light bulb is very dim, but then it gets much brighter. So the inductor is basically something which is kind of like an accelerator for electrons. I'm going to use an analogy that you probably heard of. It's called the water hose analogy. But to show you what it is, I'll need to switch screen. So this is an example of the water hose. So say that the wire is similar to a water hose, and water coming in would be electrons. First, let me draw the water. Alright, so now that I've drawn this water, let's say that we have a pump here. So we have a pump, and it's going to push the water in this direction. Now, this pressure is going to continue since water is not easily compressed until over here where it starts to turn the water around. Now, this will turn all of the water and start to push the water over here out in this direction. But at first, since there's so much water, it's not going to be very easy. So at first, it's not going to push much. Later, what it's going to do is, since it's gaining enough energy and the water is starting to move, it's going to go faster and faster until eventually it's going to be at the speed which you push the plunger or the pump in. Now, let's switch this with an inductor. Alright, now that I've drawn this inductor, the first thing you might notice is these red and blue like line things around it. So these are lines of magnetic fields. But first, we need to review something. Back in Electricity and Circuits Part 2, we talked about motors. In motors, we briefly discussed about electromagnets. Now, when an electric current is passed through a wire coiled up like this, it's going to create a magnetic field, similar to the electromagnets in that motor. Now, when this happens, one of the sides is going to be north and one of the sides is going to be south. So back to the magnetic line things. So when we create this magnetic field, let's say this side is north and this side is south. So this is north and this is south. But anyways, we have this inductor, and when electricity is ran through, what will happen is it's going to create an electric field as well as this magnetic field. Say I have a pulse, okay? This pulse is what is the input. Now what this inductor is going to do is the output is the pulse is not as much as its input. As you can see, I drew the pulse a little weaker than this. That's because when energy is transferred in, what's going to happen is the electric field will form eddies, because the electric field will create a surrounding magnetic field, and vice versa. So that will create some disturbances, which are eddies. They're basically like whirlpools. But we won't care about those. What we really care about is what the eddies actually do. They slow down the passage of energy, which makes pulses like this or like this a lot less visible. So instead of this, more like something like this. This property also makes inductors very well in circuits. Some circuits, like the circuits in computer or phone or device that which you're watching this on, the circuit board there has multiple inductors in it, at least one, because inductors can, as you can see, they can reduce pulses. And that is exactly what you want if you're designing a circuit, because you don't want a bunch of radio jam things to get in the way. So instead of hearing a smooth sound like this, you're hearing a very, very choppy noise. Something more like this. So that's how an inductor works. Okay, it's time for the question of the day. So what would happen if you had more loops, like say this much, instead of this much? Would the amount that it's decreased be more, or would it be less, or would it stay the same? Leave your answers in the comments below. Please like and subscribe, and I'll see you in the next video.